That helps to get six experience and knowledge. Bismillah. Okay. So when you when you like solve the paper, when you receive the paper in the CIE, so the best practice or which I've learned and which I've heard from many others as well is to just go through the whole paper once and see what type of questions there are. So like we'll see, okay, the first question is differentiation, second is binomial expansion, third is uh, third is also similar to binomial expansion, and then fourth is easy, it's just substitution, and then we have integration, and then we have trigonometry. Wait just 1 minute. One sec. Back. Someone call me. Okay, so sixth is trigonometry, seventh is trigonometric equations, and then eighth is coordinate geometry transformation, ninth is GP, geometric progression, 10th is again coordinate geometry, and 11th is functions. So it's differentiation and mix up. Basically, like we know the whole paper, we've seen the type of questions. So in the back of our mind, we'll know, okay, so this is the type of questions which we're gonna encounter. So our brain will start like now it will start and it will like heat up so that when at the point we will reach that question, it will already know what to expect, and so it will hopefully perform better, inshallah. And I think this is one of the most important tip for time management is when like you're solving a question, or like if you didn't even solve it, like you just on a question, just read it and you're thinking about it, and you just can't seem to figure it out, like what to do or what's like how to solve it. Don't waste that. Do not waste time on it. Like if it takes you more than 2-3 minutes to like figure it out, just leave it. Leave it at this point. And I am assuring you that when you completed the paper, when you completed the rest of the questions, and when you come back to it, inshallah, like you will be able to solve it. And again, if you are not able to solve that, just leave it again. So like let's say we did 7 questions and we couldn't figure out 3 questions. So like I did first question, second I couldn't understand it, then I skipped it, and then I did third, fourth, fifth, sixth again I didn't understand, I skipped it, and then again a rest of question, and question number 9 I couldn't understand it, and so I like again skipped it. So complete the rest of the paper, then come back again to the like first question which you skipped, then try to do it again, and if you are not able to do it, it's not a problem, just skip it again and complete the rest of the questions which you think which you skipped previously. So this is the and in that way you will save time, like you will not waste time, and you will able to complete the paper, inshallah. And if hopefully not, but if you like miss a question as well, just write whatever you think. Just give all the working as possible, which you think would be correct. And even if like the answer isn't correct, you'll at least get the marks of the working, inshallah. So it's basically how to get the most marks out of the exam, and that's uh, how you score good, inshallah. Okay, so let's start. So basically, the first question says the equation of a curve is such that dy over dx, derivative of y over derivative of x is equal to 4 over x minus 3 whole cube, for x is bigger than 3. The curve passes through the point 4, 5. Find the equation of the curve. So x is bigger than 3. They've given us this dimensions. If we put x is 3, then it will be 4 over 0, and which will be uh, infinity, like it will not be able to exist. Doesn't exist. Like it will give us an error. So that's why they've specified the domain that it's bigger than 3. So okay, so we know the dy dx. So they've asked us to equation of the curve. So we know that if we have an equation y, let's say, and we do dy over dx, take its derivative, we get its derivative. And then if we take its another derivative, then we get second derivative. But if we need to go back, we integrate it. Like we integrate d square y dx square. And again from here we will integrate this dy dx to get y. So basically what we need to do is integrate over here. So first to integrate we will write dy dx in simple like in one expression. So it becomes we bring the x minus 3 whole cube above. It becomes easy to solve. And then we'll integrate it. Since 4 is a constant, it is being multiplied, we can take it out of this integral. So it becomes 4 integral x minus 3 whole cube. It's an indefinite integral since we do not have any limits. So the the way to integrate is basically if you have x power n. So if you integrate this x power n, you get x. You add 1 to the power n plus 1, and then you divide it by n plus 1. And if you have like x 2x plus 1 integral n, then the way to integrate that is 2x plus 1 n plus 1 over divided by n plus 1 into the derivative of x, which is 2. Divide by the derivative of x. That's how basically you do the integration. So this is the only type of integration which we have in AS level Math 9709. Nothing further than that. So this becomes 4. It becomes x minus 3. Minus 3 plus 1 is minus 2. And minus 3 plus 1. And the derivative of x is 1 plus c. Since it's indefinite, we do not have limits, so it's very important to add the uh, the component. This is very important, the plus c. Don't forget this because many people, I make this mistake many times. 4, this becomes x minus 3, minus c plus 1 is minus 2, divided by minus 3 plus 1 minus 2, 1 plus c. So you can see that 2 and 2 will divide and the minus goes up. So what we get over here is minus 2. And since it's minus 2, the power is x minus 3 minus 2, we can bring it down and it becomes x minus 3 whole square plus c. And now they've given us a point. The curve passes through the point 4, 5. So we just substitute these points into the equation which we got to get this c. So y is 5 equal to minus 2 over x, which is 4 minus 3 whole square plus c. 5 is equal to minus 2 over 1 square plus c. So c is basically 5 plus 2. So c we get is equal to 7. So the equation of y we get is minus 2 over x minus 3 whole square from here plus 7. That is the equation of y. समझ आई? Okay. So a simple differentiation question. Okay. Question number 2. The coefficient of x power 4 in the expansion of x plus a wholes power to the whole power 6 is p. And the coefficient of x squared in the expansion of ax plus 3 whole power 4 is q. It is given that p plus q is equal to 26. Find the possible values of the constant a. Okay, so it's a very simple question, but it's a lengthy question. We first need to like we know that we need to find the coefficient of x4, which is p, then we need to find the coefficient of x4, which is q, then we add them to get 276. So to find the like most simple way to do that is to find a specific coefficient to x power something. We see that we look at the expression x plus a power 6. So we know that since it's the first term, it is multiplied like it has the power of 6 minus r, right? Like if you say 6c1, then x becomes 6 minus 1 and then a will be 1. So we can say that, and that is r, right? 6c r x 6 minus r. A power R. Basically, x, the power of x will be 6x minus R in this expression. So this is very useful. If we know that it's going to be 6 power, if we need to find 4, we just R2. But in expressions where there's an 1 over x over here, then this becomes very useful. Just do 6x minus R and 1 over x divided by x power whatever R there is. So this becomes easy. So now we know that the power of x in this will be 6 minus R, and we need to find the power of 4. So we just equate this 6x minus R is equal to x power 4. Since the base is the same, so we can write it as 6 minus R is equal to 4. Then R becomes. So now we know that what the R is, so we'll just put this in the equation. The expression 6c2 x to the power of 6 minus 2 multiplied by a to the power square. We get is 6c2 15 x power 4 a square. So basically, the coefficient of x4 is 15a square, which is p. So we can say that p is equal to 15a square. Okay, so this is one. Now let's find q. Same way, you know that ax, or just ignore the a right now, in ax plus 3 whole power 4. We know that the x will always have the power 4 minus r, since it's the first term in the expression. So x 4 minus r, and we need to equate that to x square, right? X 4 minus r is equal to x square. So 4 minus r is equal to 2. We found r. Okay. So um so we have this expression, right? Ax plus 3, the whole power 4. This is basically the box method. This is like a it's shortcut, because you can the like simplest way or the most straightforward way to write the whole expression 4c0 ax power 0 or ax power 4 minus 0 c power 0 plus 4c1. Let's say we write it like this: ax power 4 minus 1 c power 1 plus 4c2 etc etc 4 minus 2 3 power 2 plus 4c3 ax power 3 uh, 3 power x power 1 c power 3 plus 4c4 ax power 4 minus 4 c power 4. So like in these questions, like you can see, okay, so in which expression will we get the x power squared? So we can see that the x power squared is only in this 4c2. This is easy, like only because we only have x in the first term. But in questions, like this is an easy question comparatively. But in usually questions, you get something like x squared plus 1 over x4 or something, power 10. Then they ask you to find the power of x power 7. What will you do with that situation of 6? So in power 10, like this was just power 4. Imagine if it's 10 power 10. And I've seen questions like this. So like it's not very appropriate or possible to like expand the whole equation. So what we do is basically the box method. Which we do is, we know that this is, since this is the first term, then it will always be 4. Like this is the standard way, right? N CR x power n. Like if we have an equation x plus a whole power n, then a power r. So this is the standard form of the binomial expression. So we know that since n is 10, and this will multiply by n minus r, and this will be r. So what we do is, we say that x square will always be multiplied by power of 10 minus r. Let's take our equation over here, right? X plus ax plus 3 whole 4. So we know that x will always be uh, multiplied by the power of 4 minus r, that is n ax power uh, we can ignore the a because a is a constant. So x will be always be 4 minus r, and there is no x over here. So what we need, and you know that this is the only x we will get, and we need to find x square, right? So uh, what we do basically is like we do x4 minus r is equal to x. We basically equate the the expression which we attained. Like in this complex expression, we will get x square power 10 minus r into 1 over x4 power r. So if you like simplify it, you get x multiplies inside x 20 minus 2r over x4r. So if you like bring it up over there, it becomes x20 minus 2r minus 4r since they are dividing. So we get x20 minus 6r. So let's say let's say in this question we need to find the power of x power 8. So what we'll do is we'll equate this with x power 8, and then those two becomes equated. 26 minus r is equal to 8. Then you get 6r is equal to 12. Then you get r is equal to 6. So in this expression, if you need to find the power of x power 8, we'll just substitute r is equal to 6, like 10 c 6, etc., etc. We'll not need to like expand the whole expression. Hopefully it is understandable, right? Currently, let's take a long turn. So let's think we should have explained it in separate page. So this is a box method. It's a shortcut basically in these types of questions. This is a simple this is a simple question, but in more complex, it is very useful. So we can figure it out that x square is over here, but we just use the box methods. We know that x is 4 minus r, and we need to find power of x square. So what we'll do is do 4 minus r is equal to 2, and from there we'll get r is equal to 2. Now we put 4 c2 ax power 4 minus 2 power 3 r. So we get is 2 6 a square x square 9. So we get 9 into 6 54 a square x square, which is q. And now they told us that p plus q. Basically, no, p is that is not q. Q is basically the coefficient of x squared. So 54 a square will be q. Okay. Now they've given told us that p plus q is equal to 276. So p we calculated was 15 a square. Q is 54 a square. So 15 a square plus 54 a square, take a square common, you get 15 plus 54. This divides over there. 15 plus 54 is basically 69. So a square you get is 12. So for a square you get is 4. I don't know what was that. And hence you get a is basically plus minus 2. So it can either be 2 or it can either be negative 2. And this is sufficient. Hopefully the question is understood now. Mohit. Okay. Express 4x square minus, alhamdulillah, 4x square minus 24x plus p in the form ax plus b whole square, where a and b are integers and c is to be given in the form. Okay, so basically this is the completing square. So completing square, the steps are, you first need to get x square alone. Like there should be no coefficient with x squared. So in this, what we'll do, we'll take 4 common. So we have the equation 4x minus 24x plus p. So we'll take 4 common. You can see it's a is taken common right here, so right? 1 second. My stylus is finished. Basically, you take 4 common, get x squared, and 24, you take 4 common from 24, you get 6 minus 6x plus p. And in completing square, you may know that we what we do is basically we add and subtract so that it doesn't make such a big, it doesn't like uh, have an effect on our equation. The half of the coefficient of the x, like you know that it's 6, right? Coefficient of x is 6. So what we'll do is we'll take 6 divided by 2, which is 3, and then we'll add and subtract the square of it. So we get 2 plus 3 square minus 3 square. It's the same in all type of questions plus p. And now we know that uh, we can see that it's x square minus 6x plus 3. So we can write this as x minus 3. And since it's minus right here, so we'll do x minus. If it was plus, we'll do plus x minus the term which we just added, whole square, minus 3 square, which becomes 9. If you expand it, that is what we'll get. We get x square plus 3 square minus x into 3, 6, 3 into 2, 6x. That's what we'll get plus p. Now we just open this. We get 4, this multiplies with 4 multiplies with the x minus 3 whole square, and 4 also multiplies with minus 9 minus 36 plus p. That is the uh, expression which we are supposed to get. And we don't need to, but we can do it just for uh, examiner's sake. We can say that a is equal to 4, b is equal to negative 3, and c is equal to p minus 36. Hence, or otherwise, find the set of values of p for which the equation for x square minus 24x plus p has no roots. So, roots are the x intercepts of an equation when it's talking about roots. So, in this case, now it has 2 roots. So, it will be, so the determinant, which is b square minus 4ac, will be bigger than 0. In this case, it only has 1 root, x is a tangent, so b square minus 4ac is equal to 0. And in the case where there are no roots, b square minus 4ac, the determinant will be smaller than 0. So what we need to do over here is we just like, so it told us that equation has no real roots, so we'll go with this b square minus 4ac is smaller than 0. So p, like in this equation, 4x square minus 24x plus p. The like base quadratic equation is basically ax square plus bx plus c. So b is minus 24, 24 whole square minus 4a is 4, and c is 1 0, negative 24 whole square. That is basically 576 minus 16p more than 0. So we get 16p is greater than 576. If we take 16p on the other side, so we get p is greater than 36. So just one mark since it is. Okay, next question, Bismillah. Okay, so this is a very simple question. 3 marks. It's almost like three marks. The tool is to solve the equation 8x power 6 plus 2 15x cube. So in these questions, all you need to do is try to make it a quadratic equation, which we know how to solve because we haven't solved any cubic, quadratic, or any other higher powers. So the only way we can do that is like the best way is to create a substitution. So we can say that x cube we say is equal to u, or we say u is equal to x cube. Now we substitute that over here. So x cube, if you square x cube, you get x equal to 6, right? So there will be 8u squared, and then x cube is u, which we got as u. Now we just need to solve this. We know that u will be equal to the quadratic formula minus b plus minus b squared minus 4 ac over 2a, which is 8. So now you can either solve it with the calculator, or you can just put it in the formula, which is also which is an easier way in the calculator. You get 8 to 15. 2 we get is 1 over 8 for you. To x we get cube root basically 1 over 2, or x is equal to negative. A very simple question. Okay, integration. This is a very simple integration question. Very simple. Other questions are like area under area between two curve and a line and 360-degree rotation. That those are more complicated. Diagram shows the curve with the equation. This whatever the equation is, you don't need to worry about whatever the equation looks like because you integrate it anyway, so it will not really matter. Even if there's a power of let's say 2900, it won't make a difference. It's the same way. For x is greater than 0, okay, we can see that. Equal we see x-axis at the points 0. So this is important. And for 0. Find the area of the shaded region. वही ब्रो बोलिया करो म्यूट करके कोई इशू नहीं होता समझ तो आई है ना ये
ये अब समझ आ गई है, बस मैं एक नोट कर लूँ।
हाँ हाँ इजी सी क्योंकि वो खास बेस्ट ही होता है कि नोट ना भी करो ना समझ आ गई तो बाद में खुद सॉल्व करो बेस्ट क्या ये हो गया आपकी एक थोड़ा समझ
हाँ
लो
ये तो है।
और बट कर लो कोई नहीं इसमें
ओके, कैरी ऑन कर लो और हो गया।
ठीक है
थैंक यू।
find the area of the shaded region we just integrate it with the limits we need to area under this curve. So the limits will take the x. We'll integrate find the area of the shaded region. So it's basically integrated respect to x. So we'll do from 0 to 4, and then we'll put in the expression. Since this is a definitive integral, so we will not, we won't have any c. So now we just integrate it. We can integrate both separately. 10x 1 over 2 plus 1 divided by half plus 1 minus 5 over 2 x 3 over 2 plus 1 divided by 3 over 2 plus 1, which is 5 over 2 basically. 4. So what we get is 10 divided by 3 over 2 x power 3 over 2. Negative 5 over 2 into x power 5 over 2. So you really don't need a calculator to calculate what 3 over 2 plus 1 is, because we know that 3 over 2, we since 1 will go into 3 once and it's another 1, so we can say it's 1 plus half 1 over 2, right? So half of 2. Basically, this is what 3 over 2 really is. So it's basically 1.5. 1.5 is basically 3 over 2. Like it's 1 and half, uh, like half of 3. Sorry. Yeah. So we know 3 over 2 is 1.5. And if you are adding 1, 1 into 1.5, you get 2.5. And 2.5 is basically 5 divided by 2. So we just like calculate it mentally to save time. 5 over 2, 0, 4. Hey, yo, what do we have here? No, that's 10 over 3. But 10, since it's 10, 3 over 2 is being divided by 3 over 2, we can write it as divided by 3 over 2 minus 5 over 2 x power 5 over 2 divided by. I'm just setting this to show something which will make things easier. And since it's dividing, we can take the reciprocal. So it becomes 2 over 3 minus 5 over 2 x 5 over 2 into 2 over 5. Okay. So we're out of space, no problem. That now we multiply x power 3 over 2 over uh, divided by 3. And now let's look over here. So, 5 over 2 divided by 5 over 2, we could just like cut it right here. But I want to show this to you how it really actually cuts out 5, cuts by 5 and 2 cuts 2. We get negative x power 5 over 2. Limit 0, 4. Now we have to open the limit. Let's just do it on the extra page. Like it's not a problem. You can easily do that in the examination. 20 over 3, let's say that question number, whatever question was that,
5 है.
5. Like you write over here, question 5 continued. And you also like indicated on that question. So we got 20 over 3 x 5 over 2, no, to c over 2 minus x power 5 over 2, right? Was question. Yeah. So let's say like continue in additional page. Oh, no issue. But just make sure that it doesn't like doesn't comes on the barcode. That's problematic. Read on additional page. Okay. So we just put in the limits. So the way to do that is we first put the upper limit. So it becomes 20 4 cube over, so CO2, sorry, divided by 3 minus 4 5 over 2. And then we subtract it from the lower limit. 20 power 0 e over 2, 3 minus 0 power 5 over 2. So what we get over here is basically get 160 over 3 this term minus 4 power 5 over 2, it is 22. And this 0, 20, where it's going to be 0, 0 minus 0 is basically 0 minus 0. So that's what you get, 160 over 3. 64 over 3. ये डिमांड का क्या सवाल आपका? That's the question. Yeah. लोग की आवाज नहीं आ रही बड़ी वो खौफनाक सी आ रही है।
चेक करो कि वॉइस चेंजर तो नहीं ऑन किया हुआ आपने।
नहीं 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 यार, अभी सो के उठा हूँ इसलिए ऐसी आ रही है। अब
हाँ
सही है।
हाँ
अच्छा,
अब सही
सही
है।
है
मैंने आपको ये कहना था कि वो मुझे सर ने कहा हुआ है कि ये जो से एडिशनल पेपर है ये भी जाके चेक नहीं होता, तो यहाँ पे भी नहीं लिखना होता, यहाँ पे बस आप रेफर नहीं करनी होती है।
अच्छा,
इसके ऊपर भी नहीं आप लिख सकते, उन्होंने ये कहा हुआ है।
तो अगर जगह खत्म हो जाए तो क्या एडिशन वो एक्स्ट्रा पेज में कौन होता
नहीं,
है?
उन्होंने उन्होंने पता है क्या कहा हुआ है, आप ऊपर करो मैं आपको बताता हूँ। क्वेश्चन को लेके जाओ जरा। जैसे जैसे ये वाला क्वेश्चन था ना, आप इसको एक तो छोटा छोटा करके लिख लो, यहाँ लेफ्ट से, यहाँ से शुरू कर लो आप, यहाँ से
हाँ
आप शुरू कर लो।
हाँ मतलब आप कह रहे हो
ठीक है,
कि
और फिर बीच में आप एक कॉलम बना लो और आप फिर दोबारा शुरू कर लो।
हाँ बस सही कह रहे हो, बस यही है कि हमने इसको ना यहाँ पे
क्योंकि वो
कर
एग्जामिनर भी हैं, वो ब्रिटिश काउंसिल के, वो पेपर भी चेक करते हैं, उन्होंने बताया मुझे।
सही नहीं तो कुछ सही कह रहे हो आप। अगर हम यहाँ पे लाइक लाइन बना देना।
हाँ, बीच में आप कॉलम बना लो, कॉलम को वो कर लो, नहीं पूरा कॉलम बनाना पड़ेगा, ऐसे भी नहीं।
कितना कह रहे हो?
हाँ, पूरा एक कॉलम बना के आप इस तरफ लिख लो आधा और आधा इस तरफ लिख लो बाकी।
सही सही। हाँ मैं वैसे ऐसे ही करता हूँ, बट वो नानी सही कह रहे हो, थैंक यू ब्रो। अच्छा क्वेश्चन
क्योंकि
समझ आ
पिछले
गया?
साल आप इवन ओ लेवल में भी नहीं लिख सकते थे ये, तो यहाँ क्वेश्चन तो आगे समझ, आप ओ लेवल में भी नहीं लिख सकते थे।
अच्छा ओके ठीक है। सो so in these integration questions usually there is it's either asked under area of the shaded region or it asks area when the shaded region is rotated 360 degree. So there are two variations to that. If it says along x-axis, then you apply the formula like if this rotate this in this direction, then the formula is basically uh, integral of the limits are the same, but it's pi y square. Y is this like y square, which means that you will substitute this thing in this y. But when it says along y axis, then it is basically pi x square. Basically, in this question, they may give you like they may tell you that x is equal to like ay plus b. But if they don't, then what you will need to do, you need to make x a subject, and that isn't very difficult. It's very easy to make x a subject. Make x the subject, then you substitute x in this equation. That's how you get the area rotated 360 degree along y-axis. And in this, you can take pi common out since it's constant, so it becomes pi x squared. Then you like even it's very simple, but you just need to know these two formulas. These are very important. And when which one applies, don't like mix them up. Acha. So basically, uh, area of the shaded region when uh,
अब्दुल्ला एकदम फिर से रिपीट करना 360 डिग्री का।
हाँ ठीक है मैं करता हूँ। uh, अगर मेरे पास वन नोट हो। Basically, volume of revolution, it's a variation in the integration question. When they ask you to, let's say, like, we have this graph, right? So basically, this is the graph of this curve. And they ask you to find the area of the shaded region. This region is rotated along 360 degrees along the x-axis. So the formula, basically, you just need to memorize a simple formula. So the volume of the revolution is basically the integral of pi into y square, which is the equation like y is equal to x square, right? So it becomes a like this. These are the limits a, and this is the equation y is equal to x square with the domain x is greater than 0. So the formula to calculate the area of 360 degree along the x-axis is basically integral of pi y square. So y square, we substitute, we put this in. over here. Then we get volume is equal to pi. You take pi common. Integral AB x square to the power of square. Since it's y is x square, so x square we cancel becomes square dx. Then you solve it, and pi is always almost outside since it's a constant. And if it says along 360 degrees along the x-axis, then sorry, and on the along the y-axis. So basically, this is the same graph. Let's say this is the same graph. This graph, this is the shaded region. No, wait, sorry. This is the shaded region along the y-axis. This will be the shaded region. And they've asked you to calculate 360 degree along the y-axis. So basically, we'll rotate this graph like this. So what we get is this thing. So this is the volume we need to calculate. So the formula for this is the same formula, but we change y with x. So we say it's pi x square. And what is x square? We know that the equation is y is equal to x square. This is the same graph, y is equal to x square. But we need to make x a subject. So what we do is we say x is under root of y. And it's since it's simple positive under root, since area cannot be negative. So now we substitute this into over here. So we say the volume is equal to pi under root y whole square, and this simply becomes pi under root integral y. That's the volume of this revolution right here. समझ आइए? वन
आ गई।
वन आपको ये
हेलो, आवाज आ रही है?
हाँ हाँ आ रही है, समझ आइए आपको?
हाँ हाँ, मुझे आ गया, शुक्रिया।
अच्छा, ठीक है, next question. Okay, so this one was a tricky question. I remember being stuck in this as well. The diagram shows a sector OAB of a circle with center O. Angle AOB is equal to theta, and OP is equal to AP is equal to x. Now it's asked us to show that the arc length AB is 2x theta cos theta. They basically ask us to show this arc length. So we know that AB is equal to, basically this is the circular measure in which is in radians. So in radians, theta radians, AB will be equal to r theta. So we know it's theta, but we don't know the r. So we need to find r, right? So what we do right here is can see that since this is an isosceles triangle, both sides are same, so we know this is going to be theta as well, right? And if we make a line right in this center, this forms a right angle triangle. So, and we know that this length, sorry, is going to be equal to this length, since it's an isosceles triangle. So if we can find this length, then we can multiply by 2 to get r. So this length is basically going to be, this is the hypotenuse and this is the base. So we can say that cos theta is equal to, let's call this length r over 2, right? So r over 2, this is the base divided by hypotenuse, which is x. So r over 2 is basically x cos theta, and get multiplied that by 2. What Numan was saying, we make 2 columns, get r is equal to 2x cos theta. And so we know that AB is equal to r theta. We substitute it with r, 2x cos theta, 2 theta. So we can write it as 2x theta cos theta. That's all. So basically, in these questions which you don't understand, just try like playing with the diagram. So just check what you can do. What do we have? So I just like straight away said this because I knew this was, but it took me a lot of time to figure it out. So we know that okay. So what can we do? Like can we make a just try experimenting? Can we make a right angle triangle over here? Try make right angle triangles. They like really help a lot. So if this is a right angle triangle, so but we need to know the base, but we won't don't have this base. Okay, so this won't work, and nor do we have this. So okay, where else can we make a right angle triangle? Can make it over here, but again, this will not be suitable since it's Caesar diagram. The best, and we can make another one over here, right? And this is how we solve the problem. Just try making as many right angle triangles as possible. They like really help a lot. Find the area of the shaded region APB in terms of x and theta. Okay, so we know that area APB is going to be basically the area of the whole arc, this area, and from this area, if we can get APB by subtracting this area. That's how we'll get APB, right? So first, let's calculate the area of the whole arc, and they've asked us in terms of x and theta. Okay, so area of an arc is basically the formula in radians is half r squared theta. This is basically, I think it's given in the formula sheet. Yeah, it is given in the formula sheet from F19. So we have half r square is basically, sorry, r2x cos theta, 2x cos theta whole square into theta. So just simplify it, half becomes 4 square, sorry, 4, 2 square is 4x square cos square theta into theta. This 4 cuts out. So it's basically 2x squared theta cos square theta. This is the area of the arc. Now we need to find the area of this triangle. So we we knew that like the right angle triangle we made, we know that these are basically two right angle triangles. Like in an isosceles triangle, where let's say this is x, this is also x, and this is y. We divided by 2 is not an isosceles. We make a right angle triangle. Isosceles. Yeah, this is an isosceles. So if we like cut it from the middle, we get two same triangles. This area is going to be equal to this area. So basically, this is an isosceles, right? We can find the area of this one triangle, right angle triangle. We can find the area. Yeah, we can definitely use half AB sine C. Yeah, 100%. But for that, I think I think this will be easier. But yeah, that is how we will find the area. Sorry, yeah. That is 100% how we will find the area. Since so we know that uh this was x cos theta, right? This length over here is okay. So arc area of arc area of isosceles triangle. Let's say this of this half right angle OXP triangle OXP. It will be equal to half A, which is x, B, which is x cos theta, sin theta. So we get x squared cos theta sin theta over 2. So now this is the area of one right angle triangle, and we need to find the area of the whole isosceles triangle. We just multiplied by 2. So area triangle OAP will be equal to 2 into area triangle OXP, which is x squared cos theta sin theta over 2. So 2 cancels out. So we get x squared cos theta sin theta. And now finally the area of the shaded region, the area of the whole arc minus area of the isosceles triangle. So area shaded region. Minus this x squared theta, x squared cos theta sin theta. Let's just call this off. And now what things can we take common? Indeed. This is the formula, but let's like make it a bit more tidy. We can say we can take x common and cos theta common. So we get 2x theta cos theta minus x. Yep. This is we could take an x square common, sorry. Yeah. So this is it. The answer. Okay. Um sorry, the meeting is going to end soon, so I'm going to end the meeting right now, and then I will like restart it so that it doesn't give me a timer. So please rejoin it as soon as I end it. Okay, I'll start it as soon as I end it. Inshallah. Continue. By first expanding cos theta plus sin theta whole square, find the three solutions of the equation cos theta plus sin theta whole square. So best way to do is just do what the question says, because it knows if you like try to find other alternatives, we'll just like mess up. Cos theta plus sin theta whole square. We'll get cos square theta sin square theta plus 2 cos theta sin theta is equal to 1. So what we can do right here, we can like substitute sin square or cos square for the we know that the identity cos square theta plus sin square theta equal to 1. So we know it's just cos square plus sin, so we do it like this: 1 plus 2 cos theta sin theta equal to 1. So what we get is 2 cos theta sin theta equals to -1. So cos theta sin theta is basically equals to 0, since the 2 divided by 0 would also be 0. So it's either cos theta is equal to 0 or either sin theta is equal to 0. So we both do that separately. Cos theta is equal to 0, sin theta is equal to 0. Okay, so basically the like most quickest method is to just draw a four chords graph, four chord the Cartesian plane, and check. Okay, in the like domain of theta, which is 0 to pi, uh, theta is basically going to be 0 when I think in this question it's best, in fact it's best to like draw the actual graph of cos or sine. That is basically the best, most safest way to solve these kind of questions. So we see that the cos graph is basically something like this. This is pi, this is pi over 2, this is pi. And we need to find, we only have this domain, right, till pi. So when, so cos theta equals to 0. So uh equals to 0, this thing, this, let's take this as a line. This is basically like y is equal to cos theta graph, right? This is equal to y is equal to cos theta. Basically we taken y as 0, 0 is equal to cos theta. So in the line where y is 0, the graph cuts it at only at pi over 2. This is like, we know that's how the graph is made, right? So we can say that theta is equal to pi over 2, and that is the only solution in this case which we have. We don't have any other solution. So let's say if it was uh if it was, if the domain was 2 pi, then we'd say it was pi over 2 and uh 3 over 2 pi. That would have been two solutions. But since we have a restricted domain, that's our solution. And now for sine theta, same thing, like a graph of sine theta, like this. This is pi, this is 2 pi, and in the domain of is more than equal to pi, we get, we see that y is equal to 0. Again, y is equal to 0. It has two solutions in fact. We have 0 and it is also 0 at pi. So pi over 2, 0 and pi. That is the number of solutions which we get. So when the basic question is theta is equal to 0, or any other question, the best, this is the most safest way. But if in any other question, if you're comfortable with this, then this also works. This is a bit quicker, but this is what I am personally comfortable with. Just do what you're more comfortable with, and which is the most safer way, because it's about getting the correct mark, not like saving. Like it's not worth it to save time if you're getting the answer wrong. Better like put few more minutes into the question than get the answer wrong. Hope you understand. Hence verify that the only solutions of the equation cos theta plus sin theta is equal to 1 for 0 to 0 theta and pi are 0 and -1 over 2. So over there we did gave us that cos theta plus sin theta whole square equal to 1. And we need to try to make this into this. So how do we do that? We see if we can take the under root over here and on both sides. That's, we get cos theta plus sin theta. However, one under root of 1 is 1, but it is also -1, right? -1 whole square is also 1. That's the uh, question. So cos theta plus sin theta is equal to 1 for 0 pi under root. So what we'll do now is okay, so they've asked us to verify that only solutions. So we know that if we like put now these solutions, because since it's told us to verify, then we'll just put the solutions which they told us for 0 plus sine 0 is equal to this one, and sine 0 is 0, which to this one. So it fits the equation. Now we to take cos pi over 2 plus sine pi over 2. It is 0, sine pi over 2 is 1. So equal to 1. But they've also like asked us whether they say that it's the only solution. So we can just take another value to like just test it. Let's say since it was 0, we took half, and let's say we take pi to just test it if these are the only solutions for this domain. Cos pi plus sine pi. Cos pi is -1, sine pi is 0. So equal to -1. Okay, I think this step wasn't unnecessary. Apologies. That's the only way to like really verify that, since they only asked us to verify the equation cos theta plus sin theta is equal to 1. Sorry, I misunderstood. And it's verify. Okay. So all we need to do is put in these two solutions, check if it gives 1, then check any other solution in this domain. We check pi and it gives us -1, and so it does not fit over here. Yeah, we can't say it's cos plus is equal to plus -1 because the question doesn't say so. So it's only asking about cos theta plus sin theta is equal to +1. So that's why -1 is not the equation. So only solutions are pi over 2 and 0. Okay. P, prove the identity. This. Okay, so if we look
अब्दुल्ला,
close,
ये ऊपर वाला एक दफा फिर से समझा दो, समझ नहीं आई।
acha, okay. So basically, they asked us to, when the question says verify, so verification means to just test, to just check that if what the question says is true. So they told us to verify that the only solutions of the equation cos theta plus sin theta is equal to 1 for theta is bigger than 0, smaller than pi are 0, pi over 2. That means if the theta, all the values in this domain, the only values that satisfy this equation are 0 and pi over 2. So what we need to do is we need to verify it. To just put in the solutions which they gave us. It's 2 marks. We don't need to like solve anything. So what we do is write like we say, okay, first test 0, we tested 0, it gives us 1. Okay, that's true. Then we test half pi over 2, that gives us 1, that's 2. So then we take any other value. So the best value will be pi because it says theta is equal to pi. So we took pi, so that gave us -1. So that means that these are the only solutions, since all the solutions like they don't like satisfy this equation. And if, that is the only solution. Like if you, even if you like to make conceptually, you know that this is the cos graph, right? So this is the sine graph pi over. So when it will be equal to 0, and this is this cos graph. Yeah, this is the cos graph. So the only sorry, okay. So basically देखो ना कि the only way that when it's equals to 0, that's when sine is 0, and when cos is equals to 0, that's 1. So when we're adding it, that's the one only one we get. And when pi over 2, that's when sine is 1, and that's when cos is 0. That's the only way. And if we, any other value, if it's even pi, and it's -1 and it's 0, and all other values, they won't be equal to 1. So if we take any other value between this, let's say if we take this value, let's say we take pi over 4, then this plus this won't equal to 1. It will be like more than 1. So that makes sense, right? So only solutions are 0 and pi over 2. So, so now it says that prove the identity, this. So if you look closely, we can see that cos theta plus sin theta, cos theta 1 minus sin theta. So if you remember, if we take the LCM, then we get cos theta plus sin theta into cos theta minus sin theta. And that's similar to a plus b, a minus b. That gives us a square minus b squared. So if we can get that, let's try doing that. Cos theta plus sin theta, cos theta minus sin theta is equal to sin theta multiplied by cos theta minus sin theta plus 1 minus cos theta multiplied by cos theta plus sin theta. Okay. So what we get is sin cos theta, sin theta cos theta minus sin square theta plus 1 into cos theta is cos theta plus sin theta minus cos square theta minus sin theta cos theta divided by cos square theta minus sin square theta. So if we look closely over here, we can see sin theta cos theta minus sin theta cos theta, those cancel out. And then we have negative sin square theta cos square theta. So if you remember the identity which we use, if we like take 1 minus 1 common, we get sin square theta plus cos square theta, right? Then we add the other remaining terms which are cos theta plus sin theta. And in the in the denominator, we can see it's asking for 1 minus 2 sin square theta. So if we like remember, since sin square theta plus cos square theta equal to 1, so cos square theta plus 1 minus sin square theta. So if we substitute that, like whenever you see cos square theta or sin square theta, just remember to like try to substitute if it works. Usually works. And sin square theta plus square theta is equal to 1. So that becomes -1. Sin theta plus cos theta is equal to 1 minus sin square theta. So 2 sin square theta. So that is basically the same as cos theta plus sin theta -1 over 1 minus 2 sin square theta. Understand? Using the results of A, part 2 and B, solve the equation. Sin theta, what was A part 2? Okay. Sin theta cos theta plus sin theta and plus 1 minus cos theta plus sin theta is equal to 2 cos theta plus sin theta equal to minus 1. Or 0 to theta 2 pi. Okay. So we figured that out that they've also solved the equation. So we know that this is equal to, this whole thing is equal to cos theta plus sin theta minus 1 minus 2 sin square theta equal to cos theta minus 1. So you can see that this is the same, right? So you can think that we cut these two out, this whole expression, but it is never a good idea to cut out variables, to like cancel out variables in either side of the equation, since they also may contain a solution which we then I miss. So the best way to do this is we simplify it using 2. You don't open the bracket, you will understand why. Since minus 1 multiplied by 1 minus 2 sin square theta. Okay. So what the way to solve this is we need to have a 0 on one side. So even if we divide whole this, both sides of the equation, we won't get a 0, we will get a 1. So the only way is to like subtract it from either side. So we get cos theta plus sin theta minus 1 minus 2 cos theta plus sin theta minus 1 uh 1 minus 2 sin square theta equal to 0. Now you can see that we have cos theta plus sin theta minus 1 and cos theta plus sin theta minus 1 in both the terms. So we just take that common. Cos theta plus sin theta minus 1. And we'll be left with a 1 minus 2, 1 minus 2 sin square theta equal to 0. So now we know that for the equations cos theta plus sin theta equals to 1, the only terms which like are correct are basically theta is basically equals to, which we like verified over here, 0 and half pi. And for the other, we can simplify 1 minus 2 minus 4 sin square theta to 0. So we get 4 sin square theta, 1 minus 2 is minus 1. And this will not work since it's a negative. Oh, sorry, it's not minus, it's plus 4 sin theta. So my bad. So negative 4 sin square theta is equal to negative 1. So we can say this is positive 1. Sin square theta, basically 1 over 4. Sin theta we get is plus minus 1 over 2. And now we just use quadrants or whichever is more comfortable to you. And let me just do it quadrants as well. So in 1 over 2, and they've asked us to have this domain. So it will basically give us this kind of half is basically 5 over 6. So this will be, so this theta from here we will get is 5 over 6, and then 5 minus 5 over 6, which is 5 pi over 6. Okay, so basically, you see, I made a very big blunder, which minus into minus is plus, but I did that minus. So these silly mistakes are very dangerous. These are the all of the solutions. 5065. So this question was a bit heavy. Now I know why the threshold was so low. Okay, समझ आइए मोहम्मद
Yep, आ गई।
अगर मान आपको ये मूवी okay so 8 diagram shows the graph of y is equal to f of x where the function f is defined by 3. Okay, so basically this is a sine graph. Oof, it's a big sine graph. Wow. Half equals to sine of x over 4 for okay the domain. Basically, if you the sine graph is basically something like this. It's a very thick graph. Sketch the graph of inverse of f inverse. So f, if they've asked us to sketch the graph of inverse of f, basically the inverse of anything is basically its reflection in the line of y is equal to x, right? This is the line y is equal to x, basically to reflect it on either side. So this will become this will become this right here, that become this thing becomes this. Basically, this is like the overall shape. The vases are not so accurate, so we can go something like just make a rough sketch of how it would look like. That graph. That's how it's going to look like. The sketch of f inverse of x. Find an expression of f inverse of x. So find the expression of f inverse of x. We do is write the first initial expression as y is equal to 3 plus 2 sine 4. And now what we do is basically exchange the values of y and x. So we say x is equal to y over 4. And now we just make y the subject the equation. So you can say 2 sine y over 4 is equal to x minus 3. 2 sine y over 4 is x minus 3 over 2. So y over 4 basically becomes inverse of sine x minus 3 over 4. So y is basically 4 sine inverse minus 3. Now just put y as at 15 of x. The diagram shows part of the graph of the function or show g of x. So it's a different graph, but it's the same graph as the f of x. So they was complete a sketch of the graph diagram above. and hence explain whether the function g has an inverse. Okay, so uh, basically, if we take the sine graph, the basic sine graph, you know, it starts at 0, goes to 1, has pi, pi. But you can, if you know, to understand what they've done right here is basically manipulated this graph. They brought it to, it gave it a vertical shift of 3, and they increase its amplitude, and then they, most importantly, they increase its, decrease its frequency. This is what it actually became. It became something like this. Basically, this is what it really is, where this is pi over 4, right? Sorry, but this is 2 pi, 24 pi. This is 3, this pi. So if we understand sine graph in before it's more than x equals 0 is basically something like this, right? So this continues. So if we like extend it backwards, it's going to look somewhere like we basically need to make the like the reflection of this in this axis on y is equal to the line. So it looks like this. So it's over here. Just measure the, it starts from here and it ends at some point above, some point over here. Just like sketch this graph, something like this. Okay, again we have a timer, so let me just end the meeting and start again. So basically this is the sketch of the graph, and now they've asked us to explain whether the f function has an inverse. So inverse, the function which have inverse are basically check if the function has inverse. Just check if it is, if you draw a horizontal line, and if you see if how many times it intersects, if any of the graph, if it intersects more than once, it will not have an inverse. That's why a graph of x square with no restriction in domain will not have an inverse. The only graphs which have an inverse they if you like draw a horizontal line in any position, and it will only cut once. So if you can check in our graph, if you draw a horizontal line with it over here or over here or over here, it will only cut it once in this domain. We're not talking about it because it will cut it twice if you like extend it. But since in this domain, it only uh, f of g of x is in this domain only. So it only cuts one side. So it is has an inverse. Why? It's because has an inverse since it's only a one-to-one function, meaning that if you one value of x will give us one value of y. The problem is with with where it intersects more than once, it's because there are two values of x which are giving us the same value of y. That's why we would not have an inverse. And if you have an inverse, and it isn't a function anymore. As an inverse, since uh, it's a one-to-one function, so this is how you check if it has an inverse or not. Describe fully sequence of three transformations which can be combined to transform the graph of y is equal to sine x or 0 to half pi to the graph y is equal to fx, making clear the order which the transformation applied. So basically, this is the same thing which we did over here. Like, if we just explain what we did, so basically, we can see that firstly, uh, first it has an amplitude change, right? It has an amplitude. So if we can say, since it's being multiplied by 2, then we can say that it has a stretch factor of 2. We'll first say the stretch, then we go with the translation. We first need to do the stretch because otherwise, uh, translation it will not be, it will become 6 if we translate first. Stretch factor of 2 parallel y-axis, first transformation, and second transformation, we can see that it has been stretched with a factor of 4 in the x direct parallel to x-axis. Uh, in y direction, this stretch factor is the same as the magnitude of the coefficient of the function, but in the x-axis, it is basically the reciprocal. Since if you divide x by 2, then that if you x is smaller, then it becomes wider. It stretches like along the x-axis. But if you increase its frequency, if you do it multiplied by 2, that means that in a single of rotation of pi or 2 pi, there will be two graphs. So it is like compressing, it is not stretching. That is why it's opposite of in the y direction. Stretch factor of 2 parallel y-axis, then we can say stretch factor of 4 parallel x-axis. Then what we will do is we can see that there is a vertical translation of t, right? Relation. So the stretch really doesn't matter. You can write a stretch of x before and stretch of x y later. It will be the same. Don't make a difference. But in the MS it has stretch x forward, so I think preferably is to write the x before the y. Okay. Alright.
हाँ
Second term of a geometric progression is 16. Term to infinity is 100. Find the two possible values of the first term. Okay. So
चलेगा
unmute bro. So you value the first term. So basically so we have two informations, which is the second term. So basically the term nth term, the formula in geometric progression AR n minus 1. So the second term will be AR 2 minus 1 equal to AR. So AR is equal to 16. This is the first equation which we have. Then sum to infinity. Formula for that is all of these formulas are given in the M19 A over 1 minus R. You can check it right now. Into infinity A over 1 minus R. So A over 1 minus R is equal to 100. This is the second equation which we have. So now we need to figure out which will be the best way to solve the two simultaneous equations. So if we make R the subject, become 16 over A, that's it, 3, and then we put 3 into 2, so we get A over 1 minus 16 over A to 100. Take it to the other side. A is equal to 100. 1 minus 16 over A. A is equal to 100 minus 1600 over A. Right. So let's take A to the other side. A plus 1600 over A is equal to 100. Now we take A, the LCM of these two terms. It becomes A squared plus 1600 over A. 100. Now A squared plus 1600 becomes 100A. Now we bring that term this side, A squared plus 100A minus plus 1600 equal to 0. Now we solve A. using the quadratic formula. A square minus 100a is 1600, right? So a is basically equals to plus minus, sorry, b square minus b plus minus b square minus 4 minus 1600 2. So a we have is 80 or equal to 80. There are two values of a which we get by solving simultaneously. मोहित समझ आई, सिंपल सा था।
हाँ, आ गई है कह सकते हैं।
कैसा क्वेश्चन था, मुश्किल तो नहीं था?
ठीक था, मतलब दो इक्वेशंस बनाई, उसके बाद उससे क्या कहते हैं।
साइमल्टेनियसली सॉल्व किया बेसिकली, हमें दो
हाँ,
इक्वेशन है।
साइमल्टेनियसली इक्वेशन सॉल्व की हैं।
हाँ, कुछ भी नहीं था और कुछ भी
ठीक
नहीं
है।
था। अच्छा, now it says show that the nth term of one of the two possible geometric progressions is equal to 4n minus 2 multiplied by the nth term of the other geometric progression. So this is a fun question. So basically, we know that we have a is equal to 80 or a is equal to 20. So for these corresponding values of a, we need to find the r. So we know that r is equal to 16 over a, right? From the from over here. So for this a is equal to 80, we get r is equal to 16 over 80, or r is equal to 16 over 20. By these, you get r is equal to 1 over 5, or r is equal to 1 over 4. 4 over 5, sorry. Okay. So the nth term of this progression, let's say call this one a, this one is the first, this one is the second progression. So u and 1 will be equal to a r n minus 1. A is 80 and r is basically 1 over 5 power minus 1. So this will becomes 80 1 over 5. Let's just leave it over here. So then u and 2 it becomes 20 or 4 over 5 and minus 1. And if we like expand this, we know that if a power n divided by b power n, then uh sorry, let's say a power n, this is a power 2 or a power 1. So we can say that a power 2 minus 1. Basically, if the same term is being divided, then their powers subtract. This is like rule of indices. So we can say that 24 over 5 divided power n divided by 4 over 5, right? So now this becomes 5. Let's say this equal to one of the two. 4n 16. So if since like we can see that this question is a bit tricky and can't figure it out currently, so let's just skip it and come at it again. Just don't just waste time. This is a very important thing to remember in the exams. Don't waste your time on this question if you can't figure it out at that moment, because you'll figure it out later, hopefully, inshallah. Okay. The equation of a circle is x minus a whole square, so y minus a whole square is equal to 20. Then y is equal to half x plus 6 is a tangent to the circle at the point P. Show that one possible value of a is 4 and find the other possible value. Okay. Since it is a tangent to the circle, that means that they both are equal to at one point. So we can put y in here. Just do that. Square plus square minus 2ax plus basically half x. So x square minus 2ax plus a square plus comes 1 over 4x square plus 9 plus 3 over 2 into 3, right? 3x. So 20. Now square 1 over 4x square plus 3x minus 2ax plus a square plus 9 minus 20 is equal to 0. So how about we take 4 common in all of the terms? So we get 4x square plus x square is 12x minus 8x plus 4a square 36 minus 50 5x square plus 12 minus 8a x plus 4a square again minus 44 is equal to 0. Okay, so since it said that the line is a tangent to the point, then that means it only has one intersection. And we determined in the previous question that for that the determinant will be equal to 0 if it is a tangent. So b square 12 minus 8 whole square minus 4 into 5 into 3 which is 4a square 4 144 plus 64a square minus 192a minus 24 a square minus 44. Get 64a square minus 192a is 144 minus 80a square plus 880. Yep, 880 is equal to 0. 64a square minus 80a square minus 192a plus 144 plus 880. Let's simplify. Negative 16a square zero. So it's best to have the coefficient of the highest power positive, so we'll just take minus common. Now we can take 4 common as well. Like, no, we can, if we take 4 common, we get 4a square plus 8 minus 56. I think we can take another a square plus 12a minus 64. So a we get is basically minus b plus minus b square, or so is a is 4 and the other value of a is negative 60. Okay, so now it says for a is equal to 4, find the equation of the normal to the circle at P. Okay, so the uh, joint equation which we calculated for the intercept of the intersection of the line and the curve, it was basically this 5x squared plus 12 minus 8. Now we have the value of a. We put 4x plus 4 whole square minus 44. Simplify. The 4 12 minus answer minus 20x equal to 0 square minus 4x plus 4 is equal to 0. So the point P, the x coordinate of point P is 2. Let's use the quadratic formula, or we can even do midterm over here. 4, 2 and 2. So x, we get x squared. Okay. So we now have the value of x. Now we need to find the value of y. At P. So we just put x equal to in the line, y is equal to half x plus 6. That was the line. So we get 1 plus 6, y is equal to 7. Okay, now this is the important part. We know that in this circle, let's say this is point P where the line intersects, and this is the center. To find the equation, at point P, this is the tangent to the circle, right? So the normal will be this. This is the normal. And so, since we know that at, from the center of the circle to the circumference, the line will always, and the line, that line and the tangent to the line, tangent to that line at that point, which is P, will always make an angle of 90 degrees. So that will be the normal. So we just find the gradient of this line, which is CP, and we'll take the value of C is basically from circle equation. A is 4, right? So x minus 4. So C is basically 4. and 3, y minus 3, so y will be 3. So that's how we find the gradient, y2 minus y1, and for p, we have the coordinates 2 and 7. So m of p, we say it's y2 minus y1 over x2 minus x1. So basically it is negative 2. So now we have the gradient and we have 2 points. So let's just put that into the equation. Y minus y1 is equal to m x minus x1, which is 2, to negative 2x plus 4 plus 7. Y is equal to negative 2x plus 11. This is correct. Yep. This is equation which we get. So for part C, just for A is equal to 4, find the equations of the two tangents to the circle which are parallel to the normal found in B. Okay. So the normal, this normal, two tangents to the circle, they're parallel to this line. So they will be tangent over here and tangent over here. And we need to find their equations. Okay. So we know that their gradient is the same as this gradient, right? And we basically need to find the uh find the point find these points. So basically these points we have the gradient. So we know that the line which will intersect them both will have a gradient of negative 1 over gradient of those lines. And they will pass through the center as well. So we first figure out the line of that line, and then we put that into the circle, and then yeah. So it's best if we like draw the actual circle. No, this is the equation of the circle, x minus 4 minus 3. So circle has center at 4 and 3, right? So we can say, and it has a radius of under 20. So let's say this is a circle. And the point P is 2 and 7. Let's say this is point. Okay. So we have this line of P, and this is the normal, which we figured out. And now they've asked us to find the equations of these two tangents, which are parallel to the normal. So we know that since this is 7, the point of P, basically this will be 90 degree to that side, right? And the- these this line will form a 90-degree angle with this tangent from the center of the circle. So the distance from here to here is going to be the same as the distance from here to here, since it's the radius. and it's going to basically opposite of this coordinate. So if we can see that the um it goes it moves two to the left, like x is two smaller, and the y coordinate is um four bigger. So if you just like add two to the x over here and four to the y, you simply get the coordinate of this point. So which is
हम्म, मेरी
Okay.
आवाज आ रही है अभी?
so what we'll do is we'll find the equation of this line right here. So we know it passes through the point 4, 3 since it passes through the center, and its gradient will be time rather.
चलो अब एंड करके फिर से शुरू कर लो
Okay. And its gradient will be since it was -2, it will have 1/2. So equation becomes y -3 equal to 1/2 x minus 4. So y we get is half x minus 2 plus 3 half x plus 1. I will just put this into the equation of the circle to find the values of those 2 points. Get x minus 4 whole square plus y, which is half x plus 1 minus 3 whole square 20, right? Yep. Now we have to simplify. Square 16 minus 8x plus half x minus 2 whole square minus 8x plus 16 plus 1/4x square plus 4 minus 2x, right? Half into 20. So minus 4x square minus 8x minus 2x 16 plus 4 minus 2. So we get square x square over 4 plus 10x to 0. Multiply 4 throughout. We get 5x square minus 40 equal to 0. 40x, sorry. So x is 5x minus 40. So x is equal to 0, or x is equal to 40 over 5. So x is equal to 8. And from now we just need to put these x values into y. So over here y will be 1. Over here y is equal to 8 over 2, 4 plus 1, 5. Now we just make the two equations separately. So at the tangents, they will have the same gradient as this, right? So for this coordinate 0, 1, the equation will be y is equal to y minus 1 is equal to -2, gradient which we figured out in the previous part, x, y is equal to -1 minus 2x. This is the first equation. The first tangent, and for the second tangent, same procedure with the other coordinates, y minus 5 is equal to -2, x minus 8. So this is the second equation that you have the answer down the bottom. Okay. The equation of a curve is y is equal to k under root 4x plus 1 minus x plus 5, where k is a positive constant. Find dy over dx. Okay. So if we write y is equal to k, we can write it like this: power of half negative x plus 5. Now if we do the derivative by, so now k 1 over 2, 4x plus 1, 1 over 2 minus 1. Since the derivative of x power n is basically dy dx was equal to 1, then derivative is n x n minus 1. And if it's x, let's say ax plus 1 power n, that's why. So dy over dx will be equal to n ax plus 1 n minus 1 to a derivative of x. So the power of derivative of x, which is 4 minus 1, x will be 0. So we get half k 4x plus 1 negative 1 over 2, 4 minus 1. These two will cut that 4 out. So we get 2k 4x plus 1 under root derivative of x minus 1. Find the x coordinate of the stationary point in terms of k. So we know if this is the graph, let's say this is the stationary point, right? The turning point. So over here, dy dx is basically the gradient of the tangent at that specific point, right? So the gradient of the tangent will be 0. So we can equate to 4x plus 1 minus 1 is equal to 0. We can easily say that. So we get 2k 4x plus 1 is 1. So we get under root 4x plus 1, 2k 4x plus 1 is equal to, we square both sides, 4k square. 4x is equal to 4k square minus 1. The x is basically 4k square minus 1 over 4. Now it says that given that k is equal to 10.5, find the equation of the normal to the curve at the point the tangent to the curve makes an angle of inverse tan the positive x-axis. Okay, so what's tan -2? Basically, it's saying that find the normal to the curve. Let's say this is the point, and this is the point. This has a tangent over here, and this tangent makes an angle of around something 63.4 degrees, and which tan is inverse of 2. Let's make this diagram a bit bigger. So the tangent at this point angle will be tan inverse 2. That means that this angle, so basically tan is basically, we know tan is basically perpendicular over base, right? So which is this is also equal to change in y or change in x, right? Since this is the perpendicular, this is the base. So we can say that the tan is also equal to the uh, gradient of the angle. So tan of this angle will be equal to gradient, and the angle over here will be the same, 2. Basically, it's saying that the gradient at that point is 2. So what we do is we say that uh, 2, we substitute k with 10.5 over under root, because we need to find the x value, and we know it's tangent. So it becomes 21 becomes 4x plus 1, 4x plus 1. We could have basically put 10.5 over there, that it would have been the same for 41, 4x to 2, for 41 or for 43. So why we get that point is basically wait a minute.
क्या हुआ?
X key value, x is not, it's 1 second. We put 4 10.5 square over there. So we get wait, we just figure out the stationary point. Sorry. So was -1, 2 minus 1 is equal to 2, because that's the dy dx, right? I'm bad, sorry. I think the exported was a bit unusual. So it's basically 21 for 4x plus 1. It's basically 3, 4x plus 1, basically 7, 4x plus 1, so 49, for x is equal to 48, x is equal to 12. This is more suitable. And for x is equal to 12, we have y is equal to 66.5. And we know that since it has a gradient of 2 over there, then it will have a gradient of negative 1 over 2 at the tangent, at the normal. So the equation we get is negative 6.5 is equal to minus 1 over 2 x minus 12. Okay, that's the equation, Hanwala. Okay, so now again going to the question which we left out. It says show that the nth term of one of the two possible geometric progressions is equal to 4n minus 2 multiplied by the term of the nth of the geometric progression. So if we multiply this term with 4n minus 2, this means that it's basically 4 over 4 square power n. So we get so it's like 4 into 4. So we can cut this out with 20. So this becomes 20, 1 over 5 n minus 1. And let's just take as 4n minus 1. And so we know that if there are two terms with the same power being multiplied, then that means we can write it like that. I just take 2 power 2 multiplied by 2 power 2 or 3 power 2. 9 to 9 is 81, right? So you can write it as 3 into 3 power 2, which is 9 power 2, which is again 81. So we can write this as, since they have both have the same power, you can say 1 over 5 into 4 power n minus 1, 24 over 5 n minus 1, which is equal to this. You see that if you get stuck in some question, please do not waste time in it. And I'm 99% sure when you come back to it again, you will be able to solve it, inshallah. Okay, one last thing. I think I could have explained this question better. Is it? Yep. Hence verify that the only solutions of the equation positive. So for this, we found that the cos theta plus sin square theta had solutions theta is equal to 0, pi over 2, and pi. So basically, when we know that cos this equation has these three solutions only. So when they've asked us to verify that only these two solutions are true for this domain, we first see that cos theta plus sin theta whole square was 1. And if we take under root, we get cos theta plus sin theta is equal to plus minus 1. But we only need to consider this, right? Equal to 1. So you know that the, even this is the same thing, right? This and these two equations are basically the same. So that means that these both equations both have the same solutions, which are 0, pi over 2, and pi. So we need to verify that for this, if this equation is only equals to positive 1, then its only solutions will be 0 and pi over 2. And we can easily verify that cos 0 plus sin 0 equal to 1. 1 plus 0 is equal to 1. This is proven. Now we do cos pi over 2 plus sin pi over 2. This is 0 plus sin pi over 2 is 1. So we get 1. This is also proven. Now the only solution we have left which could have been possible was pi, right? So we check pi, cos pi plus sin pi is equal to 1. Cos pi is negative 1. Sin pi is 0. Negative 1 is not equal to 1, and this is false. So the only solutions are pi and pi over 2. Hopefully, this paper has been solved on the run.